Okay, we want to welcome everyone to our 8th Campfire. This morning we're going to be talking about, well, we have it titled here, Application Design Using Universally Unique Identifiers, or UUIDs, and actually we're going to be talking a bit more about database design using UUIDs. And so I think we've got just about everybody here who's going to get here, so we'll get started right now. So we're going to start by kind of going over UUIDs in a lot of detail. Of course, these things are used everywhere right now. Windows uses them internally, of course. You'll see them in relation to COM controls and automation objects, and they're also used a lot of times at runtime to generate unique data. Sometimes you'll see them show up in relation to crystal reports even internally with the report. Now, a UUID is a 128-bit integer, so it's about 4 times the size of a normal integer that way. But when you're looking at a UUID, there's actually only about 122 bits of randomness. There's 6 bits that are reserved to hold the version number of the UUID and also the variant of them. So turns out that UUIDs are actually really algorithmic in nature rather than just 122 or 128 bits of random data. There's 5 versions, and some of them are a little bit older than others, but in general, you'll see a lot of them still used today. And so you can kind of tell what version it is by looking at this certain display byte of a UUID. And of course, normally they're displayed in a fashion in which us humans can actually read them. So you end up having this, I think it ends up being like 38 character display format that we use for them. And these different versions, you can see here, there's one that's based on a MAC address. There's one that's based on the POSIX time. That one's also, I think, called the EDC security method. And then there's these others that are based on either an MD5 hash of something, or one of them that is significantly more random in nature. And then there's an SHA-1 version. So basically you have these pieces that are sometimes based on some standard, and then the rest of the whole thing is based on random data. So it's this combination of these two. And what that does is it makes for a situation where you have a very low chance of collision. So, excuse me, I've got a bit of a frog in my throat today. So after calculating 70 trillion UUIDs, you've got about a 1 in 25 million chance of having a collision out of there. And I give you a little number there, more likely to be struck by lightning, 5 times more likely to be struck by lightning. So when it comes to what the actual probability is of a duplicate, we use the equation that's actually used for the birthday paradox. If you have a whole bunch of people in a room, what are the odds that 2 people will share the same birthday? And with that, normally when you get up to about 60 people, the odds of 2 people sharing the same birthday is right near 100%. I mean, it is so close to 100%. For this, you would think that something like that might follow, but because the address space that we're covering is so much larger, it takes a long time before you get to any realistic odds that you're actually going to have a collision. I mean, just to get to 50% odds, which I mean is very high odds, you have to be somewhere in the range of about 45 quintillion generated UUIDs before you get there. So what this all means is that you don't have to worry about collisions. In most of the applications that we're building today, we're dealing with data sets that are so much significantly smaller than that it's not even on the same scale. So using UUIDs in your application and in your database you shouldn't have to worry at all about collisions. So they're very safe from that standpoint. Now, there are some things to consider when you're dealing with these, and you really need to to decide whether UUIDs are right for your application. Some of the advantages that you get with them that people really like is, first off, no lock contention like auto-increments. So on an auto-increment or sequence-based table, you have the possibility of getting kind of like a hotspot in relation to the sequence if you have lots of inserts being done on your tables. And when you're using UUIDs, since they're being generated from this random data and these algorithms, there is no one piece that you have to worry about from that standpoint for lock contention. Secondly, if you're using Visual Data Flex with this, of course, you don't have to worry about the proprietary nature of row IDs. So with UUIDs, we're actually treating them in Mertech's product as basically a new row type. So you can have a row ID type table or a recnum type table or a what we call a dynamic primary key table, which uses a UUID in most cases. And because this is something that basically you just have like a string access to get at the UUID, you don't have to worry about having to serialize it or deserialize it when you take it onto the web or anything like that. And of course, that means that these work on the web really well. It's very interoperable in nature when you're to use UUIDs with other products even. You don't have to worry about anything in relation to these proprietary row IDs. So they work really well that way. And of course, we've made it real easy to set up. We'll show you some of that later. And if you're doing replication or mirroring, some of the database backends actually require that you have an identity type column, unique identifier type column that you use in your table structure. And of course, this fulfills that requirement. So it makes setting that up quite a bit easier. And then this last point is actually a really important point where you can generate them anywhere, even offline. So what we've set up with the dynamic primary keys basically allows for the server to generate a UUID for you and put it into a column in your row at the server end. But depending on what you're using, let's say you have other applications that need to access this data or add rows into your tables, a lot of times certain applications don't like getting that data back dynamically, or they don't have what's required to get that back dynamically after they've added a row. And so because it's set up as a default, you have the ability in other applications to actually add a UUID from the application itself, and it'll work just fine. So that means that when you're going to use this table with some other tool or some other part of your application even that's maybe in a different language, it works really well. It's very easy to generate these things, and you just have to make sure that you generate the UUIDs correctly, and we'll talk about that a little bit later. So those are some of the big advantages of them. When it comes to the disadvantages of these, you also need to think carefully. And although this seems kind of counterintuitive, they're actually quite a bit slower than if you were using a sequence. And the reason this is the case is because when you're using a sequence, essentially you have either a pointer in memory or something like that you have to have some proper locking on, and it just the integer in that memory gets incremented as you add a new row, and you take the result back, and you're good to go. But when you're dealing with these UUIDs, you actually have to generate them. Like we said, they're very algorithmic, so that takes some time. So in fact, you have to weigh the cost from that standpoint, because they are going to be slower. Now, there is a way that we can make them a little bit faster, and we'll talk about that in a little bit also. But it's something to consider. Even the ones that are optimized to be faster are still going to be a little bit slower than a sequence is. So if you're a very insert-heavy type of user, that may be something you have to look at. Also, many people find them hard to debug. Now, I've been using UUIDs in projects for a while now, and you know, personally, I don't find them very hard to work with. But a lot of people feel because you're dealing with such a long string that it can be a little bit difficult in comparison to just, you know, an integer or something. And, you know, I can see how that'd be the case. But I find that, you know, with the clipboard, I don't have much of a problem with it. The next item here is possible index fragmentation. And we're going to go into that in more detail. I'll explain that. Actually, we're going to spend quite a bit of time on that item. And then you can't order by ID. Basically, if you're using fully randomized UUIDs, the order that rows are put in is not going to be like it would be in a sequence, where it's just this incremental number. Of course, they're very random in nature, and so when you insert a row, it can be inserted, you know, 10% into your file, or you know, 3/4 of the way down, or whatever. So you kind of lose that, and again, we're going to talk more about that and ways around that piece. And then you have to worry about insufficient entropy that can skew statistical dispersion.
Whoop-de-doo! What does it all mean, Bantam?
Well, in relation to that item, what we're talking about there is if you were to create a UUID function to generate them by yourself, you have to be very careful about doing that sort of thing, and basically where the random data is coming from and how you construct the actual UUID. You have to be very careful about that, because what can happen is if your random data isn't random enough, it doesn't have enough entropy, what will happen is you can end up with a subset of UUIDs in one area of the total address space available for them, and that can increase your chance of having a collision on them. So in relation to that, there are Windows API calls that you can use to generate UUIDs, multiple types of UUIDs even. And if you're going to rely on your application to generate them, you want to make sure that you're doing that instead of doing it yourself. So that way you're making sure that basically that the function that you're using to generate them has been vetted by someone else. Now we're going to talk a little bit more about this index fragmentation item. And but first we're going to talk about clustered indexes. Now, in relation to dynamic primary key tables, it's important to deal with what index is your clustered index, and this is something in general we don't think about a lot. You know, this is a little bit more in the database theory area, but we kind of want to go over it because in general, when you're using a sequence, if that sequence is what ends up being your clustered index, which in general is what ends up happening, things are going to be good enough. It'll be okay, and you're not going to have any problem, and everything will work okay. But when you're using UUID columns, you actually need to consider this in more detail. So first off, what is a clustered index? Well, this is basically just the index that has the data, the order that your data is stored in is the same as the order that it is indexed in for this one index. That, of course, means you only get one of these, so you have to choose wisely with it. The advice that you'll find out there is kind of oddly worded, but they tell you that it ideally should be based on a monotonically increasing value. And basically what that means is that it should be based on the value that is incremental by the same amount each time. That's what they're looking for. And of course, with a sequence in general, we get that. So if you're not using a sequence, we're looking at you know, UUIDs here. Well, what do you choose in this case? Well, you need to look at what's important for this table in your application. So often you end up with a situation where the order that the records are added in actually is the most important. And if that's the case, there is a solution for that piece of it that we'll talk about in a little bit. But maybe it's based on how you most often find your data. That may be the index that's best for your clustered index. You know, which one is essentially the most important. But I can tell you, whatever you do, what you don't want is to have a random UUID column as your clustered index. what ends up happening then is you end up with having high index fragmentation, and that is a bad thing. So now we move on to index fragmentation. What exactly is this? Well, essentially an index, to simplify down a bit, is a double linked list. So you have items that link to their next item in the list and the previous item in the list, at a very simplistic level. And basically, it's broken up into chunks of pages, or chunks or pages of pointers to the actual data. And you can end up with two types of fragmentation. They refer to it as internal and external fragmentation. Internal fragmentation is actually not something we're worried about. It's not even necessarily a bad thing in all cases. Most files start with high internal fragmentation, depending on their setup. So we're mostly going to worry about external fragmentation here. And to show you what external fragmentation is, it's best just to illustrate it. So this is looking at an index on a table here, and we have 4 pages in this index. And you can see here that in this case, the pages are laid out in the physical order, page 1, 2, 3, and 4. But as you can see from the arrows and the pointer descriptions here, that isn't the logical order of them. So page 1's next logical, the next logical page after page 1 is actually page 4, and then after page 4 we go to page 3, and then after page 3 to page 2. So we're essentially out of order here, and we are fragmented. We're in a fragmented state right now, where we don't have a match between the physical and logical order of our index. This can happen when you're inserting data midway into your file. And so in general, when you're using a sequence, of course, if your clustered index is based on that sequence, you're not going to see this very often, because you're going to be adding rows in, and essentially they're going to be added onto the end most of the times. And so you don't see this problem happen, and it will develop over time as empty space gets filled in a file and all of that, but it happens at a very low rate. When you're using UUIDs, it happens at a very high rate, because your data is inserted all over these index pages all of the time, and it's having to add index pages in between and readjust them, because we have no clue where a random UUID is going to get added into our file. So that leads to a high amount of index fragmentation, which slows down your table access. So a bad thing. How do we deal with this and still get to use UUIDs? Well, the way we deal with this is by using sequential UUIDs. And so now we're going to go over some advice on how to actually set up your table in this case. Sequential UUIDs are best supported in MS SQL right now. And essentially what they are is they are considered, I believe, a version 1 UUID, and they use the MAC address of the system, which is a guaranteed unique hexadecimal number, that allows you to basically say, okay, for this machine, I've got this unique identifier already, which is my MAC address. I'm going to use that, and then I'm going to take part of the rest of this 128-bit integer, and I'm going to make it incremental. So you have this UUID that basically isn't entirely random anymore. Part of it is unique to the system, and the rest of it is somewhat randomly generated, but guaranteed to be incremental in nature. What that does is it gives you back some of the advantages of a sequence, but without quite as much of the cost of a sequence. And of course, we end up with a situation where it's able to generate it much faster, because there's not nearly as much truly random data in it. But we get the rest of the advantages, such as the ability to merge tables together and all of that. So sequential UUIDs are a great thing. And in fact, that's what we advise if you're going to use a UUID-based table, dynamic primary key table, that you use a sequential ID for your primary key. And all of a sudden, we don't have the index fragmentation problem anymore. If having the data in the proper order is, based on when it was added, is the best for your data, all of a sudden we get that, and it's good to use as a clustered index as well. So, great item in here. Now, if you already have a good natural, what's called a natural primary key, is in comparison to a surrogate key, which is what we're generating here. If you already have a good natural key that you can use that. In general, there aren't too many of them anymore as we see this, because a natural key is something that never changes. Now, some people thought, okay, for certain tables I can use maybe social security number if you were in the United States. Well, that doesn't work as a good natural key because people, of course, view that as private information. It's controlled now under many federal laws, so it doesn't work from that standpoint. Certain people may not have a social security number issued that you need in your database for one reason or another. And of course, the social security number is an address space that is very limited in nature right now. I mean, it's very small, and it wouldn't be surprising to see either an extension to the social security number coming out at some point, or what we actually do see is even reuse of old numbers after a person has died. We'll see numbers that get reused. They have to wait a certain period of time. All of those things point to it not being a good primary key. And when you start to look at other things that people may use, you'll see that they don't meet some of these requirements either. They change, for instance, email address is one that people have thought about using because, of course, we know it's unique on the entire internet, but people change their email address regularly, and therefore it doesn't qualify. And of course, ideally, you want your primary key to be a single column, an integer, or maybe a short fixed width string. So if you don't have a good natural primary key, UUID can, especially a sequential UUID, can serve as a surrogate key in this case. And we, of course, still get to keep our uniqueness. We keep the incremental nature. So basically, they work really well in this scenario. And whatever you do, you want to make sure, of course, that you use these columns for all of your relationships as well. That's what should be done in all cases anyways. So what does Mertech support for UUIDs look like right now? Well, Mertech, the Flex to SQL 12.1 product, the beta of it has support for UUID GUID columns as your primary key on MS SQL, Oracle, and PostgreSQL. One note here is that just based on a limitation of MS SQL, if you're using any triggers at all, you cannot use a UUID as a dynamic primary key. You could add a UUID column that gets generated without any problem, and it'll work, but if that is your primary key, it just won't work in MS SQL if you have triggers in place. Now we're going to talk about the actual migration utility support, and this is something that in the current beta is not there right now. So I'm going to show you some stuff that actually hasn't even come out that way in relation to creating UUID-based tables. So you have the ability to create these tables, and here I'll show you how this looks. Okay, so this is the absolute latest and greatest build of the migration utility, and we're going to start by looking at what you get for an existing table, and if you were to restructure a table. So you'll notice on our restructure dialog we've made some changes here, and one of the items we have is we've now added this third record type. And you'll notice it's grayed out on this table. You cannot change an existing table to a dynamic primary key table just by clicking a radio button. And the reason that is because on a new table, we can set up some defaults for you, and you can choose to slightly tweak them or whatever, and that's just fine. But on an existing table, we don't want to make those assumptions for you and just have a one button change and you're done. So what we did here, if you mouse over this, you can see basically we've got some basic instructions for you, and it's pretty simple here on how you can change a table to a dynamic primary key table. And essentially, because you have some options in how you do this, we leave it up to you. But it's as simple as selecting a row ID table. You add a GUID type column, and you'll see here in the if I were to add a field in the native data types, there is a GUID type now, so you can add a column that way. And essentially, you need to put that, make sure that it has a default value. So I'll show you that in a sec. And then you you set it so that it doesn't allow nulls, and then basically you have to have an index on that. So it's a pretty simple process, just a few steps there. And that's how you convert a table. I'm not going to convert that table because I use that table in a project. So instead, we're going to go through the process of creating a table. So I'm going to say this is a dynamic primary key table, and you can see here it's done all the defaulting work for me. And so I'm just going to leave the name at what it's selected here. You can see that the dataflex type for a UUID column is selected as ASCII. That's how we make it readable and usable for you in your application. It's internally stored in a binary format for most of the backends, and so some of them can even use a variable binary data type as a GUID column, whereas some of them have a GUID data type. So we always will show it to you as a GUID here. And basically, the default value item here now is different than it used to be. It used to be that when you would put something in there, it was the value of that item. And in fact, that's still the case. So if I were to put, Joe in there, then all of the UUIDs are going to have a default value of Joe. But if you put in data in the form of a function in here, such as new sequential ID with the open close bracket, we detect that on the server as, we check to make sure that there is a function by that name, and if there is, we instead treat this as a default function for this column instead of just a default value. And you'll see here that we have a couple of different functions available for Microsoft SQL Server that you can use. So the new ID function is a built-in function that generates a fully random, I believe it's a version 4 type UUID. And then we have a new sequential ID call, again built in, that generates a version 1 MAC address incremental type UUID. And we default you to the sequential ID, of course, so that you don't have these problems related to index fragmentation or anything like that. And we're going to add a couple of columns here, just a couple of simple ones so we can open it in database. Database Explorer. Turn off allow null on both of those. And then over here on index, you can see it's added an index for us. It's marked it as a record identity and is the primary key. And we're going to add a last name, first name, index, and we're going to throw UUID in there as last segment. And then we're going to save this. Okay, and now we will pull up Database Explorer. Okay, make sure I got the right workspace listed here. Okay, there's our table. Okay, so what I will do here, we'll just show you how this works. And there we go. We have our UUID. brought back in, created on the server in this case. And in fact, we could, let's go and add another one. You can see here, now, we said that we were using a sequential UUID in this case. You can see here, these are kind of displayed backwards from what you would expect them to be displayed as. So, of course, if we were to keep adding here, you can see that our order in relation to this isn't changing, even though, of course, that's our current index. It's going to use in Database Explorer the first index. And our order didn't change at all. That's because this is the correct order for these, even though if you think about it, what is it, an 8-digit hexadecimal segment, that first segment there, starting with C is going to be higher than a segment starting with 9. They're actually kind of displayed backwards, and you'll notice that the rest of them is all identical in these cases. So all the rest of the UUID is identical. So they're actually, even though they're in the correct order, it's a bit backwards the way they're displayed. It doesn't really matter from a development standpoint, but it's something you kind of need to get used to. And in fact, if you have an actual fully random UUID that you're using instead of a sequential UUID, you probably won't even be able to notice it. I actually didn't notice this fact until I think it was just yesterday that things were kind of displayed a little bit funky. And if you go look, it's not the way Database Explorer or the Mertech drivers is showing this. It's the same way in SQL Server Management Studio. If you were to go look at that table, you'll see the exact same order for it there. So it's just the way that they're shown everywhere. So something to be aware of in that case. But you can see here that I was able to add a UUID without any problem. It's dynamic, dynamically being added on the back end. I don't have to think about it. And of course, I can find by these without any problem as well. So if I were to switch into this mode and clear the record, F9, you can see I find Jane Goodall in that case, as it should. So finding with them is, because it's being treated as a string on the visual data flex side of things, it just works in this case. So you don't have to think about that piece of it at all. It's very easy to use, and of course the format of it, we've got these curly braces on it and all of that are added to make it a kind of standard display that way. So that is basically how UUIDs function in the Mertech driver. As you can see, it's very easy to add a table with them, and from a use case, it's dead simple to use. You don't even have to think about it; it just works. Now, it also works on Oracle and PostgreSQL. The glaring omission here, of course, is MySQL. MySQL just doesn't support what's needed to make dynamic primary keys functional. So there's nothing we can do about it. They just don't have support for it. Does that mean that you can't use UUIDs in MySQL? No, it doesn't mean that at all. You can use them just fine. You just can't have them generated at the server side. You would need to generate them in your code and set them up. So totally usable still. You just don't get the dynamic part of it, and so that's what we've really added in support for, is the dynamic part of this to be generated at the server. We've had support for UUID columns for quite a while, so but when we added in this dynamic thing aspect of it, we wanted to go over all the rest of it with you as well. So next up, alternate dynamic primary keys. So if you'll notice in here, if I were to go in here and restructure this table, you'll notice I could type in whatever I wanted in here. And in fact, if I had a function called that on the server, I could use that to grab my value back to make this a dynamic primary key table based on some other type of value with a different column type even. Dynamic primary keys are supported not just on these types of columns, they could be supported in other places as well. And in fact, even if this wasn't related to a dynamic primary key, this new support for adding functions in as default values works everywhere. So that's actually kind of a new feature to use in other ways as well. But from the standpoint of dynamic primary keys, would you ever want to use something else? Well, like I say here, it's possible, but it's unlikely you'll actually use this feature. You can put a custom function in, it works, and of course we have that support in place so that if you want custom functions for default values on other columns, you can use that now. That's a new feature that's going to be in 12.1. So, you know, but as for what you could use for a dynamic primary key, what everyone thinks, and you'll find tons of stuff online to this effect, is, can I use a timestamp? And the answer is no. You cannot use a timestamp. Timestamps are not primary key material. And a lot of people think, well, if I can get the accuracy down low enough, each row is going to be added at a different time, and if you know I've got that much precision on the timestamp, I should be good. Well, no, you won't. Just to give you one example of where this breaks down, and you know you're going to find people attempting to do this everywhere, but where it can break down is in a transaction. So in a transaction, essentially everything is being treated as committed at the same time, right? So maybe you're adding 10 records all in one transaction. And in fact, if you look at timestamping in a transaction, in general, you're going to see everything in that timestamp or in that transaction timestamped at exactly the same moment in time. That's how the server treats it. Well, that of course would mean that you would have duplicates. Timestamps are not primary key material because of that fact alone. There are other reasons as well. Um, so what else could you use as a dynamic primary key? I don't know. Maybe you guys will come up with something. I haven't been able to think up anything else that that really works in this scenario. Of course, sequences have been supported for a long time, and they are a type of dynamic key. But you know, from the standpoint of our new support here, where you can do a custom function for it, I don't know. So I'm certain there are others, but I don't think it's something you'll use a lot. This UUID support is really the key to it. So to wrap this up, what's the advice across the board on this? Well, dynamic primary keys allow you to generate a record identity other than a sequence. UUIDs are what we talked about generating in this case. They're not for everyone, but they're really, really useful overall. I can't overstate how well they work on the web because you can just put the UUID out there without having to worry about nearly as much as many items as you do on a row ID based table. None of the serialization, deserialization, or anything like that. Our support in the driver for these is really good. We're able to have it in the back end as a 128-bit integer on all the native backends. You know, in the data access driver right now, they have to treat those as strings, and so they don't work really well as primary keys because they're so large. So you know, our support for it is actually going to be much faster overall, and although it's not for everyone, there are a lot of situations where you can use it, and we're using them all over the place nowadays. If you have a natural primary key that works better, use that though. That's just general advice overall. You definitely want to use that if you have a good one. And then lastly, if at all possible, use these sequential UUIDs. Now, if you're working on a different backend, such as Oracle or PostgreSQL, the support for sequential UUIDs is a little bit more difficult. It can be done. And in fact, we'll definitely have a blog post that goes up about exactly how you do that on those backends specifically. It's a little bit too big of a topic to get into here, but we will show you how that's done. So that's pretty much it on UUIDs. Hopefully I was able to give you guys a little bit of info on that you didn't know, and now if you have any questions, feel free to ask.
Hey, Oliver, this is Riaz.
Hey.
So a couple of things I wanted to point out, and even though the webinar is about UUIDs, but there's a higher concept that we're introducing in these new 12.1 driver, which is the dynamic primary key, right? So UUID falls under that dynamic primary key concept, correct? So you could actually create some other function on the back end, as you showed in the Flex2SQL migration tool, and use that as a primary key. It doesn't have to be UUID.
Correct. Yeah. You know, we've got that support there, and there are some people that are starting to do some stuff with other types of dynamic primary keys. The use cases for that right now, I think, are still kind of actually in their infancy, to be honest. So I think in you know, in the future we'll see more alternatives from that standpoint being out there. I know a lot of people have looked at some of this and realized that it matches up really well with some of the big data systems that are out there from the standpoint of these, you know, sort of tuples of data that you have in relation to being able to deal with that from VDF. This UUID support ties in really well with that because those big data systems use a very similar format to this.
Right, and also in the context of UUID, I think to support replication, you need to have UUIDs, correct?
Correct.
So if you're replicating your database across multiple servers, and I think that's how we ended up putting some native support for UUIDs 8-10 years back, I don't know, a long time ago, because one of our customers was trying to replicate data and they were running into collision. So UUIDs are really the right way to do that, and I think most databases out there do not really allow you to replicate, right? They automatically add some kind of a uniqueness to the record.
Yeah, a lot of them do that for you.
Yeah.
So, but by having this built in, some of them will make you go out and add that, and you know, they'll have to populate it. If you already have your table set up in this fashion, or you're working on new stuff and you set it up in this fashion, you don't have to worry about it. It's just going to work because it'll see that identity column, you know, a unique identifier column, and know that it can just use that.
Another question that came to my mind was that what is the advantage or disadvantage of generating your own UUID in a programming package versus doing it on the database backend?
So the disadvantage, of course, is kind of you know, where we were talking about that issue of not having sufficient entropy. So if you're attempting to do it yourself and you do it wrong, your chance of having a collision in your database can go up dramatically. So you have to make sure you do it correctly. The advantage of having it on the client, though, you know, that's kind of the disadvantage that way. You have to do it the proper way. But the advantage of being able to do that is if you're using some system, for instance, that can't get back a primary key value from the database backend, for some reason or another, you have support for that. Or if you're creating basically a whole structure all the way beforehand and you want a key assigned because you've already handed that key out to a customer before the save has occurred for one reason or another, you know, being able to have that key before you've even done that save may be important in you know, for your business logic, for instance. So all of that, you know, just works. So the advantage of having it on the back end in comparison to that is that you don't have to worry about any of that. And now with, you know, in our 12.1 driver, it'll grab that value back and basically refine the record for you after you've done the save with this key that is not sequential, which you just couldn't do before, and in fact was not an easy thing to do. So the you know, the methods by which we have to handle that are not simple, and that was one of the reasons we haven't had support for that in the past. Is, you know, it just even for some of the database backends, they didn't have real reliable support for how they handled it until recently. So there is, for instance, if you were to be on an Oracle database going to use this support, and by chance your Oracle database is on an AIX server, you still can't use this. The AIX version of Oracle has had an outstanding bug for years where it doesn't generate sequential IDs properly, and just hasn't gotten fixed. So this is a little bit newer feature from the database vendor standpoint also.
And in the context of dynamic primary key, you're saying that in 12.1, a user would be able to create a custom trigger on a backend and fill that column on insert, update, or delete, especially on insert. And it may not be may not be UUID, and it will still function the same way like we showed. Basically, if you save the value, say on John Doe, and you go to the next and you save it, you will get whatever is the trigger inserting on the backend into the file buffer.
Not quite. So let's differentiate on a point here. So I'm going to open up a table here, and we're going to look at this, the design of this one here, of the table we just created. Now, if I were to go and look at triggers, those show up right in here, and I don't have any triggers. But if you were to go and add a trigger, you basically, it takes you into this area where you develop the code for the trigger and all of that, and the system automatically will fire this when, if this is an insert trigger, when you do an insert, okay? This is a different thing. So what we're doing here with the dynamic primary keys is actually not a trigger at all. It's what's called a default value. So you can see here we've got a unique identifier type column, and in here, default value, this is where you'd normally put a true default value, like a default date, for instance, on a date column may go in here, or even putting in the current date time could go in here. But this is a function that is called not in the form of a trigger when an insert is done. And the major difference is a lot of times on a trigger, on an insert trigger, it's going to be called on every insert. If I were to have this set up with new sequential ID here, if I were to go back over here, and I'm gonna take this value, and I'm gonna copy it in here, and I'm gonna change that to a 7. So I'm now unique again, and I'm gonna call this Riaz Merchant. Okay. Notice that I was able to save that line without any problem in here, and it used the UUID I passed in. It's a true default value. So if I pass a value in, it's going to use the value that I pass in for that column. But if I don't, then that default value piece will kick in and it will assign it. So it is truly something different from a trigger, and the biggest reason to really differentiate the two is because you can't use this dynamic primary key feature on MS SQL if you do have triggers. So it's not set up in that fashion at all. That's just a limitation of MS SQL in that case. So it is something that's a little bit different. So, and of course, another way you could see this is if I were to go in and do this, I'm now going to get an error, duplicate records error on here, right? Violation of the primary key constraint because I just copied and pasted an existing one in. So that shows you that, if I'm passing a value in, my default function no longer gets called at all. So that means you can actually kind of use it either way. So if you have a mixed use case scenario where most of the time you want the server to create it for you, but for on some occasions it has to be created by the client or some third party. Let's say you were using a utility that didn't like this whole dynamic primary key thing at all on the back end. If you could set a value for that UUID in that other utility or in that use case, it'll work just like normal. So you kind of get the best of both worlds that way.
Yeah, and one final question: how would you convert? I mean, I know you showed something a little bit, but how would you, if somebody wants to use the UUID and across all their database, how would they go about doing that? Just probably elaborate a little bit, yeah.
So essentially, we don't have a way right now of doing it on a broad basis. You have to do it on a one-by-one basis. with the current version. You literally have to come in here, restructure, add a UUID column of some sort, and then create your index. So actually here, let's cancel and pick a table that I'm not going to use at all. Oh, we'll do the login table. Okay. Oh, that one is already set up that way. That was one of my test tables. We'll do users. So for right now, you do have to essentially do this by hand. So I would have to add a UUID column, set it as a GUID, and assign a default value of, new sequential ID, no nulls allowed. Come in here, add an index on that column, and in this case, I want to set that as my record identity and as my primary key, and just come through here and commit that. So, and now if I go out, if I go over here and go to the users table, you can see I've got a UUID here, and it reloaded the data in here for me. In this case, it gave me a UUID at the restructure time.
Oh, so if you have 20 records, it will still go in and fill in all the UIDs in there.
Yes.
Oh,
so cool. that can be a timely process on a large table, of course. Just because of the amount of time it takes to generate them. But yeah, it'll do that for you. Cool. And that's about all there is to it. Did we have any other questions? Well, looks like that's about it. Okay, well, actually, let me just check on this. Looks like maybe we had one here. Okay. Oh, no? Okay. Looks like we're good to go. Well, thank you all for attending this Campfire, our 8th Campfire. And of course, you can contact me if you have any specific questions about this. We have the beta still available if you'd like to take a look at the 12.1 beta. Our release of 12.1 is coming towards a little bit more towards the end of the month, so you'll be seeing 12.1 show up fairly soon here. And of course, you can visit us at mertechdata.com and or on Facebook. We've got that up there, and we will see you guys soon for our next Campfire, which we'll have the topic announced for that at some point in the future here. So thank you all for attending.